One of the most popular type of macOS apps are small utility apps that live in the menu bar. Today I'm going to show you how to make this little disk analyzer app where we're using system tools, which are command line tools, to get this data from. And then in our app, the main challenge is to get the data properly, extract the information we want, and then build this UI with a little custom progress bar and this charts here. This is part of a little bit bigger app that I already introduced in one of my previous tutorials where I talked about how to clean your Mac from Xcode files. We're going to concentrate on this part of the application. Now, before we can actually build this, I need to talk about command line tools so we see where this data is actually coming from. For example, you can get the disk space, the system, the available, and the user data. Open a new terminal window, use system commands that are already provided. For example, the disk free tool, which you have to type then df or disk free. You can provide flags of how you want to have this. For example, if I just type in df, make this a bit bigger, you see I get this table. The first line is the header. So we have the file system, the 512 blocks. Folders are taken up in 512 byte blocks, which is not very readable. And that's why it's better to use a flag, which is df-h for human readable. That is giving me this, you see here, in gigabyte or in kilobyte. So now I see the first line. The slash is just your home directory, so your whole file system. I have available size. I have the whole, this disk total size is 926 gigabyte. I used 11, this is for the operating system, and then I have available 310. This is exactly the data that I wanted to use. We can also look in the system volume data. Here you see used and available, which is a capacity of 99. This is the data I want to use. Additionally, this is also giving you some of the files that take up a lot of space. In my case, I have here this core simulator folders, which it tells me it's 18 gigabyte and 6.6 gigabyte. This is related to Xcode runtimes. So I have here two installed for iOS 18 and iOS 17. That's why they're quite big. So this tool is also useful in case you want to have a look at what's there. Now, one important note, disk free is caching this data. As you saw, it was really quickly in giving me this data. So if I make an update now to if I delete one of these really large ones, it won't be showing me this. In order to do a proper scan, you would use a different tool, which is du for disk utility. Now, if I run this now, it's going to take forever. And it's going to spit out so much files, which I definitely don't want. So we can, for example, 3 levels, and then, so it will only go from the top level 3 levels in the folder structure down. And you can say, oh, what kind of files you want to have. For example, I only want files with more than 1 gigabyte. I need to use just G for gigabyte. And it needs to be D3. Okay, now it's going through all my files, and I made a mistake because I should have specified how to output this, because it gives me this bytes format. So what I am going to add is H for human readable, and now you see it's giving me here bytes, kilobytes, megabytes. For example, this is going to be used by apps like Clean My Mac, where they really scan everything. So here you see it found 300 gigabytes of files. I have 5 gigabytes in my download folder. No, I looked is because I have a new Xcode, which is 3 gigabytes. So you see, you can get a lot more information of what files you have, and you can do scans with this. But it takes a lot longer. So now for a little utility app, we're going to use the disk-free one. This is updating the data like once a day. So we are going to work with this df. I'm not going to use the flag for H because it stands for human readable. In our app, I want to use it in a way that we can format this afterwards. So we're using K for kilobyte. You could also use M for megabyte or G for gigabyte. A lot of these commands, they do have the possibility that you add here a J, which means it's giving you the output as JSON, which is a lot easier to work with, but unfortunately this disk-free utility does not have this one. You can open the man pages to see what is actually available. So this is man df. So this is the documentation for this, where you see all of these. As you see here, H stands for human readable. The gigabyte would give me all the data as gigabyte. I used K for K, and the command we are using for the app is df-k. We get this data, and then we need to extract the information from this line by line. We need to collect the data, which I'm mostly going to use from this raw with the data mount. I'm creating a new project for macOS. This is purely macOS because these command line tools I won't be able to run on iOS, so there's no cross-platform necessary anyway. This is a disk analyzer. We are using SwiftUI. This is a very simple app where SwiftUI is plenty sufficient. I don't have any fancy lists or a lot of data, so there's no performance issues or anything that would prevent us from going this route. For this app, I'm going to use a view model to fetch from these commands. So this is the one that we're going to work on first. I'm creating here a couple of folders. So we are having view, models, and models. This is going to help me working with the data. For the model file, this is my disk info fetcher, the class conforming to observable object. The first thing is I want to show you how to run terminal commands from your SwiftUI app. So we don't do anything fancy UI-wise for now. We are just going to create a first function, which is execute a command. As you saw when I typed this into terminals as a string, so we're going to do this the same. I am here passing a string. This is a more general purpose function now for us, because obviously something can go wrong when I type here strings. Might not have the correct format. I am for now returning here an empty string. When working with command line tools, we have to use processes. So I create a process and a pipeline. This is because it was outputting information as text in the terminal, which we need to funnel to our app. If you want, you can use Xcode AI. You can use the completion in Xcode. In this case, because it's a very old API, it knows it properly. The launch path is where the command line tool is located on your file system. You can fetch this with another command line tool, but because this didn't change a lot, this is a very simple app. I try to make it as simple as possible. So this is in the bin folder. Then we set the arguments as the command that we are going to use here, and we start using the standard output of this pipeline. Then you can start this process executing it in a shell, as in the terminal shell. We are waiting until it's finished, and then we are getting the data from this file. So this is just a data blob, which we now can extract this information as string. So this is string from data. I'm going to use here guard. Else we're going to actually throw an error, which I need to define here. So we're creating our own little error. And in this case, we're going to create a case of invalid data, which I then can here throw. I need to exit this process by telling it wait until exit. And then I can use the output that I had here and return this. You can also check the process termination status. So this is information about if something this is another way of getting the error from this. So we can create another error. In this case, we're going to name this command failed. And I'm here passing the error code. So everything is fine if the termination status is 0. We only proceed normally if this is 0, else we are again throwing another error, which is the one that we just had. Failed. The error message will be then in this string here. This function is very general, and you can run all kinds of commands with this. So for testing purposes, let's go into content view and add this view model. Set object var fetcher This is my disk info fetcher. And I add here a button, fetch, where I can call this function for the command that we had, which was df. And I said K for kilobyte. Now this is the output. And for now, I'm ignoring the error, so try question mark, print output. And if not, if it's nil, then just none. So this is just the first test. Okay, I have this very simple fetch button. If you press this, you see we get here this whole output with all of these lines. And the next task, as you see, is to actually parse this into usable information for our application. If you look at this information, I have the first line I should probably ignore because this is the table header. And then I have all these columns and they're separated by a tab or empty space. This is not ideal for parsing. If I would have JSON, I would prefer JSON. We are first creating a little helper model that transforms this raws and proper data, and then we extract more data from this. So the first model we are going to create is a disk info, import foundation, struct disk info, where we create properties for each of these columns that you want. For example, you can say file system, string, let size, this is an int 64 in kilobyte because this is how we specified this. Then used size, available. So I just go through all of these columns. We don't need to use capacity and is used, but I definitely want to have the mount point. Okay, we have now some helper struct that we can use to continue this. So I have now the string output, and what I want to have is a function that parses this. So parse output to our disk info. Now, because this is here in lines, things are getting a little bit more complicated. We are starting by going through line by line and separating them. I added a fallback to make sure I don't delete something. I delete the first line because this is the table header to make sure I don't crash. I check if I really have that many lines. And then I go for each line and create the disk info each line, which I might not be able to because maybe I don't have all the data. So in here, I'm simply checking these components by an empty space and then extracting them as my disk info. It's not pretty, but unfortunately, we have to work with these string types. And then in case I don't have anything, I'm creating another error case just to keep track of where things might go wrong in all these parsing steps. So now that I have this disk info, I like to make this a little bit easier to show in my UI. I don't need all of this data. Mostly I care about this line. Let's add something to my disk info to get the information. For example, is system volume. And in this case, it is if I have just a backslash. So this is making it easier for filtering. And the system data, this one, now we can easier filter this. You can make this even more easy by adding an extension to array, where I can get from an array, I can ask from this array that we had the system volume. In this case, it filters and gets the one where this property is true, or the is data volume. This is just helping us in the next step, where we want to parse the disk info to something that I can use in my UI. You see, I want to have a small list. List means we need to work with for each, so identifiable. And I like to have just these 3 entries, system available and user data. Right now I have this more messy data that I just want to make easy for myself. So we need to have just 3 data points with 2 values. One time I just want to know the name. So this would be system available user data. How much space they have. For these rows, I also add a total in each of them. So we also can have another property for total. I'm creating another model, which we can use in the UI. This is In my models file, I'm calling this formatted disk info, importing foundation struct. This needs to be identifiable because we are using then with some of the SwiftUI views. What do I want to have? For this identifiable, I'm making it easy for myself and just create here UUID. Then the title, this is the one that I want to show for each of these rows. The size in 64 and the total size. Okay, this is the rough data that I wanted to have. In this function, we are going to take the more general data and creating something that I can easily use in the UI. This is the formatted disk info. I am creating here an empty results array with the correct data. Then the total is in this info, is the system volume. That's why I added this. This is this array extension. The size. This is this raw. And the size. This is then this block here. Next, I wanted to have some of the data ones. So I need to use this volume next. This is the data volume. This is the info data volume. If I can get these, if this is present, I can create a new formatted disk info with, this is the user data, and this is the data volumes used. And the total size is just the total that we had here. And this I then append to my results. Then I had here the available data, and then the last is actually the system one, which is in a different mount. This is the system mount. So I actually need to check let system volume infos system results append this info. This is then system. This is then the first row here, where the data comes from this raw with the used one. It's a little bit harder to see in kilobytes than in megabytes. So this is the system volumes used with the total. The total is a little bit double, but I just want to present. I have this total double here. You will see in a minute when we use this in the views how much easier it is if you properly format this. Okay, now that I have this, I can return here my results. I have now 3 functions that we need to put together. So all of these are actually private functions. So you can add here private, and then the one that I'm going to call for my views is info, where I call these 3 functions now one of the other. So the first is just the output, which was execute this command, which I had in the view already. Then we are going to have the infos. This is parse this output, and then formatted disk. Okay, I did have them all throwing, so I should add a try. I wanted to run this in the background, so I'm wrapping this here in a try await task detach user initiated, and then in this I am running these and returning this value, and this function is going to throw and return the formatted disk info, and I am making this an async function, which means because of this concurrency I need to add here actually self and here return from this task the formatted disks. Okay, so now is the question of I can now run this command from my views, but then we need to think of what do I want to do with these errors, and where do I want to put in these formatted disk info. I prefer to keep this in this view model, so we would have bar disk info. This would be then this formatted disk info. We can add a arrow, and we can add is loading, so that this information is stored in here. Okay, going to content view. When do I want to start this fetching? And we can do this with a background task. So I can call fetcher dot get this info. This button doesn't work anymore. So try await because this is 1. Because it's throwing, we are using here a do catch block. If I catch an error, my fetcher's error gets this new error, and my fetcher's disk infos gets then these. And for testing purposes, I am now showing here the fetcher's disk infos count. Since I don't have any data, I'm going to just quickly debug this and add some breakpoints for the parse function and for disk info in this formatted. So build and run. We're going in the parse outline where I have the output with this infos. So I'm just going to go through. So the infos are 15 values. And I get here this correctly parsed. If you tap here, you see, okay, then I go to the next breakpoint for going from disk info to the formatted one. Because I used here this string values, I probably have just some typo. So going through, do I get my total? I already don't have this total, so I probably have something wrong with the system volume. I'm going to print this output here again. I usually don't see spelling mistakes. So the one that I said I was looking for is this. Okay. The problem is that I have the wrong name. So I'm not using the file system name because, for example, I'm using the mount name. So this should be mount point. And in order to get a better repetitive output, I added another flag for -p. So now when you build and run, you should have 3 entries that we have fetched. So this is then finishing the part, hopefully, with fetching, and we should have the data. Next, I want to work on the UI, and there's a couple of things I already know I need to do. And the first one is we have here these size as integers, but I want to have this as human readable, and we're using a special formatter, which is the byte count formatter. I create a computed var for the formatted size. This is the byte formatter, byte count formatter, string from byte count. In this case, I am setting the count style to 5, it makes sense. One thing to note is this is actually byte, but I have already loaded this data as kilobyte. The problem is I can't write, otherwise it gives me 512 bytes, so there's always some conversion problem. Because I loaded it as kilobyte, I'm missing 1000 factor, which I'm adding now here. I know it's a bit confusing, but we need to make sure in the UI that it makes sense. Then I want to have a formatted total size where I use the total size. Let's use an example. Take var example. I said in my case it's something like 11 gigabyte, which means this would be times 25, and then it's another 25. And the total size would be something, in my case, 900. Okay, let's see if my calculations make sense. And I'm creating another group for views. This is a file from template. It's a SwiftUI view for this raws that I had set. So this is the disk info raw, where I give the info, which is this formatted disk info, and in the preview I use this one example. Now we have some data. For now, let's make it easy and just show the title, the info's title, and the info's formatted size. Xcode previews are usually very small, so I'm just going to add padding and a fixed frame. So we have this data, and then the next view I wanted to show is the list. This is disk info list view. So I could either use the view model or just pass in the disks infos as an array. That's making it a bit easier for me now with the preview. I can use this one example with the lists of disk, the info, and for each disk info in. So for each information, I show this here in this disk row. I only have this one sample data. That's why it's a little bit boring now, but we can connect this in my content view. Here, I can show my disk info list for the fetchers disk infos. Now you should see data that is actually fetching from your real data from your disk. So we have these 3 data points that we want to use, and I can work on improving the UI a little bit. And here I can change the font to have monospace. I want to show a progress bar styling. In this case, making this custom. I embed this in a VStack, and below here in with geometry reader. So we can use a rectangle. This is now expanding really high because geometry reader makes everything stretchy. We are going to add a frame around it with a height limitation of, let's say, 6. So this is a small one. If you don't see it, you can always go in the selectable preview in. So now it's a square, and I want to have this with rounded borders. We are using a clip shape of a capsule. Maybe just need to zoom in more. Now this is with rounded borders. Next, I want to show a indicator of how much of the total width is taken up by this. And for this, I need to have the percentage of whatever category this is over the total one. So I go back to the formatted disk info to create another convenience. This is var percentage. In this case, it's double. This is the size divided by the total size, and now we need to figure out the type conversions. Because this is integers, this dividing doesn't really work, so we need to first convert each of these individually to double, and then it can properly calculate this. Okay, I have now a convenient way to this data. This whole formatted disk info was just to easier consume this data in the views. So I just can add more computed properties, whatever makes your life more easy. So now here I can add another rectangle, and we're adding a frame where the width is the proxy's size. So now it will be the full width, but I want to do this percentage wise, and for this we're using the info's percentage. In my case, this is very low. Now let's just think of what the colors are, and I want to have different colors for each of them. I'm using a computed property because it's specific to this view. I'm adding this here, so I create a computed property progress color. Here I check the info's title. I know I should have maybe used an enum instead. Also with different languages might be a problem, so definitely something to improve. I can now use these for the color. This is blue because it's a system, and we're going to go to content view. And yeah, this is too wide. So width of 300. You see here there's 3 categories with these data points. I can remove these texts and add actually a nice title. This is a disk analyzer with a font of title 2. And the alignment, let's go for leading. Now I do have here these annoying separators in the lists, which we can get rid of in the disk list info view. List or separator visibility hidden. Although I think I need to attach this inside the view, the list. Yeah, list is a little bit annoying, so you need to have 2 levels. So list, and in the list for each, and to the for each you attach this list row separator. So let's hope I get rid of it now. Yes. Okay, this is this first section. Instead of a list, you could have also used a group. Go to my list info. So instead here now I use a group. For the previews, I prefer to use fixed frames just so it doesn't do this. This needs to be a group box. Group doesn't do any styling, but I want to have this group box. You see, I have this nice border now here. You can also add a label to this that appears above. So this is then here, this disk overview label. Okay, this is the first section. And the next one was this pie chart, which I'm going to do in a separate view. This is again a SwiftUI view. Disk info chart. Now, similar to my list, I need to have the data points. It's just this 3 points I want to show in this chart. For easy or prototyping, having this one section is not good, so I need 3 data points. Going to this example, I create another static var examples that generates an array. So the first one is the one we already have. I need 3 of these. This is system available, let's say 300, and then user data 600. And now I have something a little bit more convenient to show. This is also convenient if you're working with this list. Then you would use the formatted disk info x. Okay, nice. Adding this preview data is quite convenient, especially now that we're working on this chart. So, we have a frame. This is the charts API, and for this you need to actually import charts. I have another tutorial about charts, so I'm not going to make this too long here. The data is my disk info. This is identifiable. Info, I need to create another section. This is a section, sector mark, where the angle is one time the name. So in this case, it needs to be the info's title. And the other one is the value. Let's just go for the info's percentage. Then I need to change the foreground style, otherwise all of these sections look the same. So after the section mark, I'm adding a foreground style where I tell it to change the foreground style depending on the title. Now we see these 3 sections. You can do a lot more. I'm just going to add something that makes it more like a donut style, which I need to add here inside the section marker. This is actually too big. In the app, it's more like 150. So we're going for 300 wide. I want to have the legend actually on the right side. So the charts legends is on the trailing edge. You can add annotations on top. So this is inside the charts. For each section I want to have a different annotation. In this case I'm saying the percentage and then as percentage. So it's easier to see how much data is taken up. And then I want to have a little bit more corner radius. The corner radius has to be applied to each of the section markers. And then here, these corners are more rounded. Okay, I think I played enough with this. And we can use this now in the content view. So after the disk info, I show this chart with the fetchers disk infos. So here it's below. Just going to go in the live preview. I will make this title bold and add a little bit more spacing. Okay, now that I have the main views finished, we want to actually use this in the app. If you run this right now, it will just show as one window, but I want to have this in as a menu bar extra. So we go into the Disk Analyzer app, and I'm not using a window group, I'm using a menu bar extra with content and label. So the content is the content view, and the label is Disk Analyzer. I will use the drive, so you could use here just one of these drives, like these icons. Then, when you run this, the app will appear in the menu bar. The first time it's complaining, this is because it's trying to restore the scene that I had before and it can't find it. So, I need to copy my bundle identifier to delete the... Then open terminal, to delete the settings of to relaunch, I need to clear user defaults. So this is defaults, delete, and then my bundle identifier. Okay. When you run the app, you see this rather funky looking app. This is because the styling of the Menu Bar Extra is a list of buttons. For example, here, screenshot X, this is a list of buttons where the styling makes sense, but in this case, I want to have more window style. So going back here to Menu Bar Extra style, if you go for window, it should be looking more interesting now. So this is my app. The main issue now is to decide on the sizing, because with these menu extras, it's trying to restrict them to decide how large they should be. I didn't set any sizing restrictions, so let's just add a frame width of 300 and a height of 400. You can also set this to these individual views. So maybe I should add a restriction to this donut, not in the height. Here in the info charts, I'm going to add a frame of height 150. We'll see how this looks. If you want, you can add more padding and sizing, but you see it's working correctly. It's giving me the data and fetching it. We are working with command line tools, preparing it for use in the UI. So there's a lot of smaller things involved. But that's the thing with this kind of utility apps. Users could go to the terminal and do this themselves, but it's not really user friendly a lot of the times. It's much easier with these command line tools. And there's a lot of them available. If you want to learn more about command line tools, there's a couple of books that teach you about command line tools in the terminal, which gives you good inspiration of what people are actually built, and you will see quite a few commands that apps use. As you see, we managed to do this in under an hour. The next step, if you're interested, is to actually publish these apps. I did publish the full app on Gumroad, and I'm going to show you the full process of self-distribution with the stapling, the DMG file in the next video. So you can see how easy it is to publish your own apps outside of the App Store. Go watch that now. Thank you for watching. Happy coding. See you next time.